Okay, so our essential question for today is how do we find the volume of a rotated region? So there are two main methods that we'll go over. Number one is the disk and washer method. And number two is the shell method. And you'll see that these names match up with some of the techniques that you'll be using during the method, so that makes it easier to remember.
The formula for a disk and washer method is basically taking the integral from a to b of f of x squared pi dx. So what f of x squared pi is doing is it's taking little areas, circle areas I mean, and adding them up to find the total volume. So let's do an example. To find the volume of f of x is equal to square root of x minus 1 rotated around x-axis from the interval 1 to 5, we would take this integral. So 1 to 5 square root of x minus 1 squared dx pi. So essentially what this formula is doing is, this is the graph of square root of x minus 1. And when you rotate it around the x-axis, this is the volume that you have to take. And this is the x-axis. So this graph right there is still f of x. So when you square f of x and you multiply that by pi, you're taking the area of those little circles and adding them all up from 1 to 5. And when you do that, you would find the total volume of that region, which is, when we take the integral, it's equal to 8 pi, which is the volume of that region.
Okay, so we're going to go over the second method called the shell method. So the shell method should only be used when the disk method won't suffice. So suppose we have a function y equals x minus 3 squared times x minus 1. We want to rotate this about the y-axis from x equals 1 to x equals 3. So from x equals 1 to x equals 3, this function looks something like this. So now if we did want to use the disk method, our disks, which would look something like this, have thickness dy. But the only problem with that is we can't integrate this function in terms of dy. So we have to use another method, and that's where the shell method comes in. So basically, with the shell method, we take cylindrical shells of thickness dx, and we rotate that around the y-axis. So we get a cylindrical shape. Which has a thickness of dx. So as we all know, the lateral surface area of a cylinder is 2 pi rh. So now we have to substitute these variables with things we know about the function. So we know the radius is just this distance x from the y-axis. So we can substitute r with x, and h is just this distance f of x. So we can make hf of x. And when we multiply this by dx to get the volume and add up all the little cylinders from 1 to 3, we get this function. So now once we simplify this, we get 2 pi integral from 1 to 3 of x times x minus 3 squared times x minus 1 dx, which comes out to 4.8 pi.
We're going to do another example using the disk and washer method, but this one's going to be a little bit different. So we are going to take the volume of y equals x squared when it is rotated around the y-axis. So this is the graph of y equals x squared. And when it's rotated around the y-axis, it's going to turn out something like that. So what we're going to have to do is take little areas of those circles and add them up to find the total volume. However, this is going to be a little bit different than the last example because we are going to have to take dy's instead of dx's. So to do that, we would have to express f of x in terms of, we would have to express y equals x squared in terms of y. So y equals x squared is going to equal, it's also the same thing as square root of y is equal to x. So to find the area of that circle is going to be square root of y, which is f of x squared dy, or just pi, I mean, to take the integral, and then we would have to add this up. So then we would take the integral from a to b of that dy. So as an example, if we take the integral from 1 to 5 of square root of y squared pi dy, which is equal to 1 to 5 y pi dy, this would equal.
Alright, now we're going to do a second example of shell method, but this time it's going to be with two functions. So suppose we have the functions y equals root x, y equals x squared, and we want to rotate the area, in between these two functions around the y-axis. So the first step is to find what that area is. So we have y equals root x here, and we have y equals x squared here. So we're trying to find this area. So first we have to find the bounds of integration. So obviously they both intersect at x equals 0, and some simple algebra will show you that both these functions intersect at x equals 1. So remembering our formula from earlier, 2 pi rh, we have to find an expression for r and h. So in this case, if we take this sliver dx, r is still x, a distance x in this case, but h is a little different. When we do problems like these, we have to take the top function minus the bottom function to find the total height of the cylindrical shell. So in this case it would be square root of x minus x squared. So putting this all together, we have the integral from 0 to 1 of 2 pi x times square root of x minus x squared dx. So we can simplify this, and this is going to equal 0.3 times pi.
Alright, we're going to do another example, except this time we're going to use something called the washer method, which is basically a variation of the disk method. So the problem we're going to do is we're going to take a region bounded by x squared is equal to 4y, and y is equal to 1/2 x, which looks like that. And we're going to rotate this region around the x-axis. So when you rotate it, the region would come out to look something like that. So it's going to be kind of a cone-shaped thing with an inner cone that's not filled out. So what we're going to have to do to take the volume of this region is we're going to have to find the area of the circle that's bounded by the line, so the line y equals 1/2 x rotated around the x-axis, and subtract that by the circle that is created by x squared is equal to 4y. And that's exactly what we're going to do in our integration. So to integrate this, we're going to take the equation 1/2 x squared minus x squared over 4 whole squared dx, and we're going to integrate it from some interval. So as an example, if we want to take the volume of this region from 0 to 2, so we're going to take the integral from 0 to 2 minus x squared over 4. This is equal to 0.27 pi. As an added note, you have to notice that the bounds of this integration are the intersection points. So you have to start from the intersection you have to start when they first intersect, and you can only take the integral up to where they end the intersection. So for example, the integral can only go up to this point right there.
So now we're going to do another shell method example with a slightly different twist. So suppose we have the two functions y equals 2 root x minus 1 and y equals x minus 1, and we want to rotate this area around the line x equals 6 instead of the usual y-axis. So what does this look like? We have our graph y equals 2 root x minus 1 here. We have our graph here, and we have our graph y equals x minus 1. And then we have the line around which we revolve it, x equals 6. So the solid that is formed is going to look something like this. And basically now, just as before, we have to take a cylindrical cross section of thickness dx. So again, we have to find our 2 pi rh. So r in this case is slightly different from before. It's the total 6 minus the x that it takes to get to the function. So we're left with a radius of 6 minus x. And our h, similar to how we did it before, top function minus bottom function, is 2 square root of x minus 1 minus the quantity of x minus 1. So now we take our integral, remembering that the bounds are where the region is cut off. So we have at x equals 1 and at x equals 5. So it's the integral from 1 to 5 of 2 pi times 6 minus x times 2 square root of x minus 1 minus x plus 1 dx. So if you solve that, you get the answer 272 over 15 times pi.
We are going to be doing another example using the washer and disk method. This time we are going to determine the volume obtained by rotating the region bounded by y equals x squared minus 2x and y equals x about the line y equals 4. So this graph is going to look something like this. You're going to have y equals x and then x squared minus 2x, so this is the region, and you're going to want to rotate this around y equals 4. So when you rotate it, the whole centroid is going to look something like this. This part is x squared minus 2x being rotated around y equals 4, and then it's hollowed out by the line y equals x. So to do this, we are going to have to take little washers of the outer area and subtract it by the inner missing circle. So the area of each washer is going to equal pi times negative x squared plus 2x plus 4 squared minus 4 minus x squared. And we're going to want to add up all these little areas through our interval. So in this case, our interval is going to be from 0 to 3. And so the area is equal to pi times negative x squared plus 2x plus 4 squared minus 4 minus x squared dx. And this is going to end up equaling 153 pi over 5.